In this presentation, we are going to look at various debugging windows that are available inside Active-HDL. The first debugging window is the console window. The console window serves a lot of purposes, which include displaying error and warning messages. One unique feature about the console window is that if you have any kind of error or warning, if you double click on that error, the tool automatically opens the source of that error. This is called cross-probing. Let us make the necessary change and compile the design again. Now you can see that the error message has disappeared. The next debugging feature is breakpoints. In order to enable breakpoints, you need to first make sure that you have the enable debug option set in your design settings. Since this is a VHDL design, we are doing it for VHDL section. If it's a Verilog design, we have to enable in the Verilog section. Click apply and OK. Now you need to compile your design again once you have enabled the debug option. Once your design is compiled, you can initialize your simulation. Once the simulation has been initialized, you can place breakpoints in your code by clicking on the column to the right of the line number. This will place a breakpoint. If you click again, it will remove the breakpoint. Let's run the simulation. As you can see, this breakpoint has been hit. Let's assume we would like to track the value of Q. So in order to do that, we have to add it to the waveform. The structure window is also a very useful window in Active-HDL. Using the structure window, you can browse through the hierarchy of your design. Let's open the hierarchy that we are interested in and select the signal and add it to waveform. Once you add the signal to the waveform, you can step through the code in order to track it. But the only problem is, now that I'm stepping through the code, the tool automatically goes back to the source code. If I have to view the value, I have to again switch back to the waveform. In order to avoid doing this, we have something called as the watch window. You can add the signals you are interested to track to the watch window, and then you can step through the code and see your values change. Let's run. So now the breakpoint has been hit again. You can see the value has changed, and you can also see the last time when the value has changed. The next debugging window is the processes window. The processes window can be used to see in which process the simulation is currently at. Right now you can see in the processes window that the simulation is at the process on line 37. If the process was labeled, this will display the label name of that particular process. The next debugging window is CallStack. In CallStack, you can take a look at all the local variables inside a particular process while stepping through the code. Let's remove the breakpoint. And let's add all the signals from the top level to the waveform. Let's run the simulation until the end. Now, as you can see in the waveform viewer, it is difficult to see all the values at one time. But if you want to take a look at all the signal values in a tabular format so that you can take a look at more data at one time, you can add the signals to the list viewer. Let's open the list viewer and then add the top level signals into the list view. So as you can see in here, you can take a look at the values of all the signals at each clock cycle. You can right click on the top column and uncheck show hierarchy in order to remove the hierarchy. You can also adjust the columns to make it more readable. Thank you for watching our presentation.